Okay, so we have another one that's going to be a mixture problem. We've got a contractor who wants to make 500 pounds of concrete with 10% cement. Concrete and cement are they're different. We don't need to go into that, but they are in fact different. So they're going to be used differently. Okay. He has he has two different types. Type 1 is 6%, type 2 is 12%. And he wants to know how much of each to make 500 pounds of 10%. Okay, so our equation, as we know, and again, we're going to start be using these in decimals, right? Because the percentages, they're going to be they're going to be very specific. So one of these is going to be, we're going to be trying to solve for, they need to add up to 10% of 500. So how we're going to write that out is going to be 0.06x plus 0.12, right? Because we're adding these. 500 minus x equals 0.10 times 500. Okay. So just like we did before, we're going to send these guys in. And 10% of 500 is going to be 50. We're going to send these guys in. It's going to look like 0.06x oh, shoot. X plus 60 minus 0.12x equals 50. Let's get that guy a little closer. My handwriting being quite big. Okay. So when we combine these guys, right, we've got a little bit bigger of a number here, and we're going to have to combine it with this guy. So it's going to be kind of an interesting one. It's going to make it minus 0.06x plus 60 equals 50. Okay. We're going to move this to the other side. Minus 60 minus 60. And we've got negative 0.06x equals negative 10. Now, we're going to divide it by negative 0.06 divided by 0.06. This is where this is going to be kind of fun. I'm going to do this a little bit different. I'm going to do this. I'm going to times this by 100. I'm going to do the same by the bottom. And that's going to equal us x equals negative 1,000 over negative 6. Okay. Okay. We're going to change these numbers up a little bit so that they make a little bit more sense. They can help us. Okay. So since we're dividing two negatives, x is actually equal to positive 6 divided by positive 1,000, which makes it 166.67. So now we solve for 1 Keep it continuous. Oops. Okay. And again, that's going to be one of the types here. So we're going to minus, we know the total is, and keep it continuous. We know that we want a total of 500 pounds. 500 pounds minus 166.67 equals 333.33. Fun little number. I'm going to write that down. I think that's going to be 6% is this, so that is equal to 6%, and 12% is equal to 333.33. numerical answer so everybody knows exactly what we're talking about. Ready to go. So that is how you kind of interplace. And again, it's kind of like a comparison, right? We're gonna walk down exactly what piece is equal to what piece. We've got the percentage here, we've got the percentage here. Here's the basis, right? We're trying to solve for x. We know that we want 500 pounds, but it's going to be minusing x to determine exactly what x's placement is in this. And then here's our final result, is we want 10% of 500 pounds. Okay, so it's a little bit backwards and it's kind of confusing. And then once you get into scenarios like this is another super, fun little objective is when you start dividing by negatives here. It looks like I forgot my negative, but the point still stands that we're going to be piecing together all of this as useful as it can be, and this will come up at one point. So, problem number one. Okay, so we have another contractor here, and he's trying to determine how he's going to make a total result of 60% gravel as a base for driveway, right? He's got pure gravel, but he doesn't really want to waste it on this, and he's got 30%. And he's got probably some other stuff inside of these. So we know that we have 100%. We know that we have 30%. We want to make 60%. Let X be pounds of pure gravel, which is 100%. Let me write that down. And then 400 minus X is the amount of 30%. So again, we're going to be keeping these numbers in our head. So the 30% mix contributing is going to be written out in decimals. So that's another thing we got to keep in our minds. And it confuses me, but it's pretty straightforward. So again, for pure, we're going to use 1.0x plus, see, and so it begins 0.30 times 400 minus x. Let's start again. How about that? Let's go a little bit further. So, 1 second. Okay. Let's do this. Let's write out the whole piece here. Let's go 1.0x plus 0.30 x equals 60. 400. Okay, so that's going to be our equation. Now we're going to solve for x. Okay, so I'm going to calculate the right-hand side first. So we're going to bring these in. We want just one. We want to know exactly what these pieces are. So okay, so again, we're going to transport all these over. So let's try to rewrite this. So this is equal to 240. A little bit kind of a times you by percentage. And again, that's 60%. That's our total. That's what we want. So then we're going to kind of bring these other ones in. 1.0x plus 120 minus, sorry, minus 0.30x is equal to 240. Okay, and we're going to combine our like terms. So whole number x minus 30% of an x is going to be 0.70x plus 120 equals 240. 120, 20.70x is equal to 120. Okay, we're going to try to solve for x. Divide by 0.70, divide by 0.70. X is equal to 171.43. So now we're going to put, well, X is the amount of pure gravel. So we already know that it's 171 percent. And if we know the total is 400, 400 minus 171.43 equals 228.57, 30%. So it's going to be 228.57, 30%. We use a lot of 30%. Let's try to keep it continuity. Here's our final answer. Here's our final answer. There you go. So that's how we're going to mix two different kind of pieces. We're going to use them as a base, and we're going to compare them against each other. So it's kind of the same thing as one of the ones we're going to do in the future here with our dump trucks. Okay, so here's another construction problem. It's a uniform motion problem. This is going to be number 3. We have a group that's hauling materials to a job site. One of the dump trucks leaves a little bit earlier, one of them leaves a little bit later, but it's faster. So dump truck A is leaving at 30, another truck leaves 1 hour later at 45. So we have a difference. We're going to use A as the 30 miles per hour and B as 45 miles per hour. And again, we know the distance is equal to for rate times time. We don't have time besides number A. We know that it's time plus 1 in comparison to truck B. So we can set them equal to distance because they will meet. So this one's a little bit tough to kind of work together in your head, but it's going to look a lot like this. 30 t plus, make that t just a little bit bigger. It looks kind of like a plus sign. T plus 1. And then, right, so B is equal to 45t. Okay? Just stick with me here. We'll get through this. Right, so we're going to distribute 30 into both. So that's 30t plus 30 equals 45t. And then we're going to move them to the same side. So 30 equals 15t. We're going to divide both our sides by 15 to isolate t. T is equal to 2. Now, all that really means is that truck B, oh shoot, almost. Sorry about that. Truck B catches up at 2 hours. Now, we can test that by putting that back in. we should get roughly the same number. But that's how you do uniform motion for a construction site. Okay, so here we are at number 4. Again, in dealing with construction and the logistics for construction, which is always super fun to think about. This is our uniform motion problem. Okay, this is number 4. And what we've got here is 2 dump trucks moving at opposite ends of a 120 mile site, big site. Imagine Australia. And truck A is empty and it's traveling 10 miles per hour faster. So now we've got a comparison. Then dump truck B, dump truck A has been traveling for 2 hours. Dump truck B has been traveling for 4 hours. So sounds like we're going to have, we're going to be doing kind of a comparison and a substitution here. So what I like to do is remind myself that we're going to have rate times time equals distance. Okay. And on top of that, we're going to have A, we're going to have B. Let's hold on. I'm gonna position this just a little bit different. So I'd like this right above. Maybe rate, maybe time equals distance. Okay. There's a multiplication part in there. All right. So we know that dump truck A is going to be doing faster than, so X plus 10 because he's going 10 miles per hour faster. And we know the time because he's going 2 hours. And we know it is equal to distance because they're both traveling on the same distance. Okay. So the rate for B is just X, right? Because he's the one being compared to. We know that he's been driving for 4 hours. We know his distance is 120. Following with me? Okay. So we know that A plus B equals C. All right. So we're going to move to another page. We're going to try to bring this with us. Okay, so like I said, they're both equal to 120. So we're gonna kind of carry on here. We're gonna change our font coloring just to keep us kind of in line. And again, we've made our graph, and again, we've set them both equal to 120. So we're going to combine them, and that's going to look like this. X plus 10 times 2, because we're multiplying them according to the table. R times T equals D, and they're both equal to D, plus 4X, because those guys just combine, equals 120. Okay. So again, we're going to distribute 2x plus 20 plus 4x, 120. We're going to combine like 6x plus 20 equals 120. And we're going to minus 20, 6x plus, sorry about that. Thinking about our next step. 100 divided by 6 by 6. X equals 16.67. Okay, now we have X. And all we need to do now is add 10. We'll find a little, I guess not. Maybe we'll do it sideways here. Let's keep it clean. So X plus 10 equals 26.67. So A is going 26.67 miles per hour. Truck B is going 16.67 miles per hour. So now the contractor knows that um, one of the trucks is going significantly faster. He already knew that, but he wanted to know exactly how much faster. And if that stays in continuance, he can do, an endless amount of more equations to determine how exactly he's going to proceed. But again, useful and helpful. Okay, for number 5, we are going to be working with another contractor who wants to figure out some information. He wants to find out exactly how much he's paying for this. He's signed his credit card, he's bought a bunch of stuff, and he's trying to track it down, right? Um, this is going to be an applications of systems. Number 6 is going to be 3D. This one's 2D. We're gonna solve it a little bit different than we're gonna solve number 6. Okay. So um, again, we have taken all the information into 2 separate equations, right? We took 50 cubic yards of gravel, 40 cubic yards of sand for project number 1. Total cost $3,500. 30 yards of gravel, 20 yards of sand, $2,100. Okay, project 1, project 2. We separated them. We are going to solve for elimination. And I like keeping it color coded. So let's multiply this bottom one by -2 to see if we can get the y alone. Again, we're just going to kind of solve them together here. Okay, and again, when we make any changes, we need to rewrite them. So we didn't make any changes to P1, we're going to rewrite it. 40y 3,500. We're going to drop a dollar sign just because I think we're all on board now. -60x minus 40y equals -4,200. Cool. We're looking good. We're looking like we're getting closer to solving this. Okay. So what we're going to end up with over here, we have 10x equals, what's that? 700. If you divide this by -10, -10, negative divided by a negative is a positive 70. Okay. So this is going to be our gravel. That's how much we paid for both. Okay. So now we have a solution. And we're going to just plug that one straight back in, see if we can follow this. So I'm going to take P1, the original, and I'm going to plug it in. So we're going to replace this. 50 times what we just found, $70 for gravel, plus 40y equals 3,500. Okay, now 50 times 70, 3,500 plus 40y. Do you see what's about to happen here? Can you imagine this contractor is pretty upset about this? Minus 3,500. Wait a second. 3,500. I can feel him getting angrier. 40y equals 0 divided by 40 divided by 40. Y equals 0 because 0 divided by anything is still 0. So we have just found the price for sand. Excellent. Sand is no cost. These are both cubic yards. Maybe this is good, maybe this is bad for him, I'm not sure. But again, it's applicable because We paid a bunch of bills, and now we want to find out exactly why and how we paid for them. All right, everybody, welcome back to algebra use for construction. So with this problem, we're going to have a 3D equation, right? We know we have a certain amount of hours total. We know we have a certain amount of hours for each department, and that's our total hours. And we also know how long it takes for each one of these projects to be done. So below, I've totaled out what each one equals. 2,000 hours for the framing, 1,400 hours for painting, 1,300 hours for drywall. And if we if we keep going, I've made them into a table. So the master bedroom is going to take 2 times the framing. It's going to take 4 to do the kitchen and 8 to do the living room. Okay. And these are all going to be plus. Okay. And so that's all for framing. And for painting, it's going to take 1 for the master bedroom, 3 for the kitchen, and 6 for the living room. It's going to take 2x, again, plus, a few pluses. For the kitchen, it's going to be 3. And for the living room, it's going to be that. Hopefully that makes sense. Again, we get into kind of 2 sections here. On the left, on the y-axis here, it's going to be framing, number A, painting, number B, drywall, number C, and then on the x-axis here, it's going to be master bedroom, kitchen, living room. So what we got is 3 equations, right? But we need to make sure that they're equal to something. So let's rewrite these in piece. So zoom in a little bit here. A is 2x. Well, maybe let's do this a different color. What do you say? Maybe 2x plus 4y. Oh, it's a little close. Plus 8z is equal to the amount of time framing, which is 2,000. Okay. Does this start to make some sense? Let's go back. Let's just do, here's B, here's C. These are going to get quite big. So this is how I'm going to break these down. You can do this a different way. And again, we're going to carry down the painting, which is 1x, it's just x, plus 3y plus 6z equals the total amount of hours, which is 1,400 for this department. Okay, got a lot of different things we keep in the back of our head here. Next is going to be drywall. So we want to make sure that we keep these guys in order. 3y plus 4z equals 1,300. Okay. So we'll check our work. 2,000, 1,400, 1,300. 864, 864, 333, or 433, 212, 2, and then there's an assumed 1. All right. So now we've got kind of our bigger picture here. We're going to move down. Hold the add page. Okay. All right. Now we're going to pick 2 of them and bring them down. I've got the equations written off to the side, so stay with us here. But we're going to bring either A, B, or C, and we're going to compare, I think, A and C. So let's do that. Bring down A. Ooh. Let me slim this down just a little bit. Yeah. Okay. So here's A. Let's change up the color. What do you say? I like green. Green looks nice. A is going to be 2x plus 4y plus 8z equals 2,000. And we're going to bring down b, which, or no. We're going to bring down c. My apologies. Okay. And c is quite similar, as you can see. Right? And our goal is to eliminate from one of the variables. Plus 3y plus 4z equals 1,300. Okay. Now we've got our sections. Now we need to solve for a variable. Well, the easiest way I can think of doing this is going to be timesing a by -1 to get the x variable by itself. So let's change colors to keep us cohesive here. -1. Okay. And then we're going to do our solution down below this. So every time you do this, we're going to need a whole new rewrite here. So let's change our colors one more time just to show that we're delineating. So it's -2x minus 4 minus 8z. This is where it's going to be a lot of fun. Minus 2,000. See? Fairly easy. And as you can see, we're going to bring down c. It's going to be 2x plus 3y plus 4z equals 1,300 positive. Okay. So right off the gate, we can see that we've canceled out x. Okay. Now let's make that a little bit more clear. X is gone. Now we're going to solve for both of these. So -4y plus 3 is -y. So let's see if I can get the solution a little bit better here, maybe. All right. That's a -y minus 4z equals -700. And since we just amalgamated a group, we're going to call this D. That's what we're going to call this. Okay. So we don't have to deal with this right this very second, but we're gonna keep that one in the back of our head. Okay. So moving forward, we're going to take two more and continue to solve. So I'm going to choose 2 and 3. And again, I have these written off to the side, so just stick with me here. So I'm going to bring down 2, which is x plus, let's label these. Well, yeah, let's label these 2 and 3. And 2 again is x plus 3y plus 6z equals 1,400. And 3 is 2x plus 3y plus 4z equals 1,300. Okay. Now we're going to again try to isolate x and get rid of x. We can just get rid of him so we can compare them later on. Okay, so the best way I can figure to get rid of x is going to be timesing it by -2. Okay, and again, once you do this part, you have to rewrite it. Okay, I know it's a lot of different colors here, but just stick with me, it helps my brain. -2x. I'm gonna buy negative. -2x minus 6y minus 12z equals -2,800. We bring down the other one. 2x plus 3y plus 4z equals 1300. And again, we're just going to compare here. So let's see if we can bring this to fruition. Right away, I see that x's are gone. They've canceled out. So we have left is negative 3y minus 8z equals negative 1500. Trying to figure out how many units these guys figure out. We're getting closer. So just like we came up with kind of an amalgamation of two up here at D, we're going to call this E. Call this E. Let's keep it cohesive. Let's circle it in red. Okay. So we're going to take E and D, and we're going to compare them to solve for the variable. I think we're going to choose y as our variable. So we're going to take our solutions. Restart this. So this is going to be D and E. Okay. We've got, make sure we got, we're going to do, make sure we're going to do E and D. It shouldn't make a difference. Okay. So we've got negative y, which is weird. Just keep with me. I know that's probably irking a lot of us out there. And again, we want to isolate one of the variables. So the most apparent one that I can think of is going to be getting rid of z. Let's multiply the bottom by negative 2. Okay. So we're going to compare these where negative 2, a negative times a negative is a positive, which makes it 2y plus 8z equals 1400. That worked out great for us. Yeah, that's a nice number. The top one, we're just going to carry it down. 8z. All right, so right away, these guys cancel out. Okay, so we're going to kind of change our colors again. That's a lot of colors. Negative y equals negative 100 divided by negative 1 divided by negative 1. Y equals 100. Okay, we're going to circle that in red because now we have found a variable. That changes things. So now that we've got a variable, we are going to plug it in and solve for another variable. We're going to plug this into the easiest one we've got, which is going to be solution E. I want to do that. We know E as above is, no, I apologize, it's D, my bad. There you go, negative y minus 4z equals 7. So we're going to replace y. So it's going to be negative 100 minus 4z equals negative 700. Okay. We're going to solve for z. Okay. That is a z, by the way. Z equals 150. Negative times a negative is a positive. There we go. All of our answers circled in red to keep us in line. Okay, so we found y and z. Okay, we're going to take these two variables and we're going to solve for the last variable against any of the equations, right? I'm going to use number 2. So And 2 is kind of a long one. Let's look for this. 3, 6. Cool. So it's going to be, let's see. Number 2, which is x plus 3 times 100. It is y. Oh, I wrote that up from here. Okay. Plus 6 times 150 equals 1400. It's a mouthful. It's a mouthful. We're gonna send them in. Oh, too many there. Okay, so it's going to be x plus 300 plus 900 plus 1400. That is a 4, I know. We can combine like terms. So x plus 1200, nice easy round numbers, equals 1400. We get rid of the numbers of the variables alone. X equals 200. Okay, now what do all these numbers mean? We've got keep continuity here. We have x, y, and z. So 200 is x, y is 100, and z is 150. So if we go back to our original problem here, let's see, x, let's write this out. X is equal to 200 master beds. Y is equal to 100 Z is equal to 150 there. So that is how many our team can do with the allotted amount of hours. They're very efficient on master bedrooms and living rooms. The kitchen take a while. Thank God for that. There you go.
So we've got a self-written problem. And a painter needs to make 250 gallons of paint that is 30% high gloss. So we've got high gloss, a premixed batch that contains 10% high gloss. What amount of each is 250 gallons? So it's going to look like we've got here. We have 100%, and we have 30% to make 10%. So we know we've got. All right, and then we're just going to write out 1.0x plus what amount of 100% will make this percent? That makes sense? So they have this and they have this. How much combined make this? Okay. So we're going to solve for x, which is going to give us high gloss, right? Because we're doing for the 10%. And we're just going to solve. We're going to distribute. This is going to be plus 5 minus 0.10x equals 75. Okay. Then we're going to combine our like terms. This one's going to send this one to the negative 0.90x. Oh, 25 minus 25 minus 25, 0.9x equals 50. Divided by 0.9. This is another weird ending of this, right? This is going to end us up with a weird number. So what we're going to do is we're going to multiply this by 100. And that's going to equal 5,000 over 90. 5,000 divided by 90 is a decimal. So x equals 55.56. Man. Of all right, we know the total amount is 250. So this is the way that I would do it. 250 minus 5,556 equals 194.44. So let's see. 5,556. 194. 10%. Makes sense? Yep. Okay, so we've got an extra uniform motion problem. A construction company is hauling gravel from a quarry to a job site. A dump truck and a smaller flatbed are used to transport. The dump truck traveling at 40 miles per hour. The flatbed is traveling at 30 miles per hour. The flatbed leaves an hour earlier than the dump truck. How long will it take the dump truck to catch up? So the dump truck is traveling at 40, so he's going a little faster. The flatbed's going at 30, and he's got an hour head start. And we know that they're going the same distance because it didn't say any different. And we can set them to one another. And so we can make our equation look like this, where we've got the dump truck plus its time, and then we've got the flatbed plus an hour, right? Because that's the non-stationary. The dump truck would be the stationary in this. Now I begun this, but actually did this wrong. Well, the first step is we're going to distribute. Then we're going to end up with 30t plus 30. We're going to subtract 30t, and we're going to end up with 10t equals 30. divided by 10, divided by 10, E equals 3. So it's 3 hours. That will be four. There. Pretty straightforward. Remembering to set them to one another can be tricky. And then there's always going to be a stationary. And then there's one where it has a plus, right? Or a minus. It's going slower by an hour. It's going slower by 3 hours. One of them is changing. One of them is stationary. The dump truck, and this would be stationary.
Okay, and for the entirety of the project, we sourced all of our inspiration from these sites. And all of our pieces, we had to turn into different use cases, but so they all started as different origins of mixes, but the concept was the same. Flower pots, how do I mix pure flower soil into 100%? How do I mix this? And then they were replaced with uses. But there you go. Thank you for watching. I appreciate it.